In this video, we're going to do some mixed review problems involving the algebra of limits. So we're going to compute some limits using these limit rules that we've learned previously. I've got them all listed here. So let's go ahead and try to compute this limit, and we'll refer back to the limit rules as we need as we compute the limits. So first of all, the limit as x approaches 3 of this quantity to the third power. The power rule says that whenever we have a limit and the inside is the function is raised to some power, we can move the limit inside of the power. So let's do that here. So let's move the limit inside the power, and we get limit as x approaches 3 of 2x to the third minus 7x squared plus 7. And we'll move the power outside of the limit, or move the limit inside of the power, however you want to think of it. Okay, so now we've got the limit of just this sum of terms, or difference, but really just plus negative 7. So it's just a limit of a sum of terms, and the addition rule says that when we have a limit of a sum of functions, we can just break it up over the sum. We can distribute the limit over the sum. So let's do that here. So we're just going to distribute the limit over the sum. So limit as x approaches 3 of the first term 2x to the third, then plus the limit as x approaches 3 of the second term, negative 7x squared, and then plus the limit as x approaches 3 of the third term, 7. And all of that is going to be raised to the third power. Alright, so now let's go through these terms one by one and compute these limits. So the first term, limit as x goes to 3 of 2x to the third power. Well, we know from the constant rule that when we've got a constant multiplying a function inside of a limit, that we can move the constant to the outside. So let's do that to simplify the limit. So move the 2 to the outside. 2 times the limit as x approaches 3 of x to the third. And then we'll do that same thing here. Negative 7 moves to the outside. So we've got minus 7 times the limit as x approaches 3 of x squared. And then here, this 7 is just a constant function, and we know that the limit of a constant function is just the constant itself. So this limit is just 7, just evaluates to 7. That's all it is. So plus 7, and then all that to the third power. And now let's go ahead and keep on simplifying. So this is 2 times, the limit as x goes to 3 of x to the third. We know using the power function rule here that we can just plug in the limit into the power function. So this limit is just going to be 3 to the third. So 2 times 3 to the third. And then minus 7 times, same idea here, we just plug in the 3. So 7 times 3 squared, and then plus 7 at the end, all that to the third. And now we're done doing all the limit stuff, and it just remains to actually compute this. So this is, 3 to the third is 27, and then times 2 is 54. Then minus 3 squared is 9, then times 7 is 63, and then plus 7, all raised to the third power. 54 minus 63, let's write that down here. That makes negative 9, and then we add 7 to that, so then we get negative 2. So this is just negative 2 to the third power, and negative 2 to the third power is just negative 8. So that's our answer. That's what this limit evaluates to using these limit rules. Alright, so here's a bit of a tougher problem. We've got a more complicated limit that we want to compute, but we're going to do it the same way, just using our limit rules to evaluate this limit. And we'll start off by noticing that this is a fraction inside of the limit. It's a quotient, so that means we can apply our quotient rule and break up our limit. We'll do the limit of the numerator divided by the limit of the denominator. So let's go ahead and write that down. So that's just limit as x approaches 2 of the numerator, so of x times 7 minus 3x divided by the limit of the denominator. So limit as x approaches 2 of the square root of x plus 1 squared minus 7. All right. So now let's treat the numerator and the denominator individually. So the numerator, what can we do here? Well, this is a product, x times the quantity 7 minus 3x, and we have a product rule that tells us that we can split a limit up over the product. So we can just take the limit as x approaches 2 of x times the limit as x approaches 2 of 7 minus 3x. And then on the denominator, well, the first thing that we see inside the limit is a root, and we have a root rule that tells us we can just move the limit inside of the root. So do the limit first and then take the root afterwards. And let's do that. So that's just the root of the limit as x approaches 2 of the inside of the root here. So x plus 1 squared minus 7. All right, so what do we do next? Let's look back to the numerator. Limit as x approaches 2 of x. Well, x is just a power function with power n equals 1. So we can just plug in the value 2 here into the function. So that becomes, well, when we plug 2 into the function x, we just get 2. So that's just 2. And then times, now this is subtraction here, and you can think of it as plus a negative 3x, 7 plus negative 3x, and then we can apply the addition rule and distribute that limit over the addition. So 2 times, let's put this in brackets, 2 times limit as x approaches 2 of 7 plus limit as x approaches 2 of negative 3x. And then the denominator, we can do the same thing here, apply the addition rule, treating that negative 7 as plus negative 7 at the end. So limit as x approaches 2 of x plus 1 squared plus limit as x approaches 2 of negative 7. All right, let's go on to the next step. So we've still got a 2 times something out in the numerator. And now limit as x approaches 2 of 7. Well, 7 is just a constant, so because it's a constant function, the limit is just still the constant. So 2 times 7. And then according to our constant rule, when we have a constant multiplying a function, here we've got negative 3 constant multiplying x, we can just move that constant out in front. So 7 minus 3 times the limit as x approaches 2 of x. All right, now let's look at the denominator. So we've still got a big old square root sign here. And here, this is a power rule thing. We've got a quantity raised to a power, and whenever we have some function raised to a power, we can move the limit inside of that power. So this just becomes the limit as x approaches 2 of x plus 1, all that squared. And then limit as x approaches 2 of negative 7 by the constant function here, that's just equal to the constant, so just minus 7. And why don't we move this up here so we don't run out of space. So we've got 2 times 7 minus 3 times, all right, this is limit as x approaches 2 of x. X is, again, a power function with n equals 1, so we can just plug it in. So 3 times 2 Nice, the numerator is, all the limits are out of the numerator. And then for the denominator, well, we can distribute this limit over the sum. So over the square root of, let's distribute that limit over the sum. So limit as x approaches 2 of x plus limit as x approaches 2 of 1, and then minus 7. All this is squared though. Almost forgot about that. All right, so let's proceed onwards. So the numerator, that's 2 times 7 minus 3 times 2 is 6. And then in the denominator, we still got the square root, but now we can actually evaluate these limits. Limit as x goes to 2 of x by the power function right here. This is just a power function with n equals 1, so we can plug it in. So that's just 2. And then limit as x approaches 2 of 1. Well, 1 is just a constant, so this limit is just 1. So 2 plus 1, and that's all squared. And then minus 7. And we're good to go ahead and compute this. Great, we've got all the limits out. So 2, the numerator goes to 2 times 7 minus 6 is just 1 over square root of 2 plus 1 is 3, and then 3 squared is 9, and then minus 7. So we've got 2 on top, and then square root of 9 minus 7 is 2, and then 2 divided by square root 2, that is just, well, just to be explicit about this, let's think about multiplying by root 2 over root 2 to rationalize that denominator, and we just get 2 root 2 over root 2 times root 2, that's just 2. So just root 2. You could have also just seen that because 2 divided by 2 is root 2, because root 2 times root 2 is 2. But either way you think about it, the limit just comes out to root 2. Here's an example that mixes things up a little bit. We want to compute this limit here, but we have f of x and g of x within the limit, and we have a graph that tells us information about f of x and g of x. So we're going to eventually need to compute the limits of f of x and g of x as x approaches negative 2. So why don't we just get that over and done with off the bat. Let's look at each function. We want to find what is the limit as x approaches negative 2 of f of x, and we want to also find what is the limit as x approaches negative 2 of g of x. So looking at f of x first, so that's this function here, just a straight line, and as x approaches negative 2, what does the function value approach? Well, it gets really close to negative 1, the first tick mark. So limit as x approaches negative 2 of f of x is negative 1. Even though it's not defined at negative 1, that doesn't matter when we're talking about limits. We only care about what value does it get close to, and it gets close to negative 1 as x approaches negative 2. We don't care about what actually happens at negative 2, just as we get really, really close to negative 2. Alright, so how about the next one? G of x. So g of x is this parabola, and we see that as we approach x equals negative 2, the function value approaches 4. So that's our limit. That's our limit. Even though it's not defined at 4, that's okay, because that doesn't matter when we're talking about limits. We just care where does the function value approach? Where does it get close to? And it gets really close to 4 from both sides. So that's our limit. Okay, so now let's look at this limit and let's compute it using this information that we have here about our functions and using our limit rules. So first of all, we notice that there's a product between two big terms here. We've got this term to the 4th power, and then we've got this cube root term, and that's a product between them, so we can split the limit up using the product rule here. So this becomes the limit as x approaches negative 2 of that first term in the product of the 2f of x over g of x plus x to the 3rd plus 1 to the 4th term times the limit as x approaches negative 2 of that cube root term. Cube root of 2g of x squared minus 5f of x squared. Alright, so now to compute each of these limits, in this limit, we see that this whole term is raised to the fourth power, and according to the power rule, when we have the function raised to some power, we can move the limit inside of the power. So we'll go ahead and do that here. So this becomes the limit as x approaches -2 of the function inside of the fourth power. So 2f of x over g of x plus x to the third plus 1. And so all that raised to the fourth power. And then it's the same idea with this root. We have a root rule, which tells us that we can do the same thing. We can move the limit inside. So times the cube root of the limit as x approaches -2 of 2g of x squared minus 5f of x squared. Alright, so now it's time to keep on simplifying. So in this limit here, this is a quotient, so we'll apply the quotient rule that allows us to split up the limit over the numerator and denominator. So this is just limit as x approaches -2 of 2f of x over limit as x approaches -2 of g of x plus x to the third plus 1, and that's all to the fourth power, then times the cube root of, well, our addition rule here tells us that we can split up the limit over addition, so let's do that. So we've got limit as x approaches -2 of 2g of x to the squared, then plus the limit as x approaches -2 of -5f of x squared. Sorry, that's running into our limits here, but you can still tell what limit is what. Okay, and let's go ahead and compute this. Because we're going to be running out of room, we're going to combine some operations simultaneously in some of these, and I'll be very explicit when I do so, so don't worry about that, but just a heads up. So here we've got a constant multiplying this function, and according to the constant rule, we can bring that constant outside the limit, so let's do that. So that's 2 times the limit as x approaches -2 of f of x in the numerator, and then in the denominator, let's split this up. So this is limit as x approaches -2 of g of x. Let's put a bracket around here too, of g of x, then plus limit as x approaches -2 of x to the third, then plus limit as x approaches -2 of 1. That's to the fourth power. And then in the cube root, let's do some operations simultaneously here. So first of all, this is a constant multiplying this function squares, so we can bring the constant out in front. And then we've got the limit of the function squared. But remember, from the power rule, we can move the limit inside of the power, so we can move it inside the squared. So we can just write it as 2 times limit as x approaches 2 of g of x, and square that. And same idea with this minus 5f of x squared. So that becomes minus 5 times the limit as x approaches, forgot the negative there, so x approaches -2 of f of x squared. Okay, so now it's time to go ahead and plug in for our limits. So this top becomes 2 times the limit as x approaches -2 of f of x, which we know from right here, that's -1. So 2 times -1, and that's all divided by the limit as x approaches -2 of g of x, which we saw was 4. So 4, and then plus limit as x approaches 2 of x to the third, and that's a power function, so we can just plug it right in. So that's plus -2 to the third, and then plus, well, limit of a constant according to constant function, that's just 1. It's just the constant itself, just 1, and that's all raised to the 4th power, and then times the cube root of 2 times the limit as x approaches -2 of g of x squared, and limit of g of x is 4, so we can write 2 times 4, and then squared, and then minus 5 times limit of f of x squared, and the limit of f of x we saw was just -1. Okay, so now we've got all our numbers plugged in, and it just remains to compute this thing, and we're going to do that pretty quickly because we're running out of room. So this top here is -2, that's 2 times -1, then over 4, then minus 8, because -2 to the third is 8, so 4 minus 8, and then plus 1, so plus 1, that's to the 4th power, and then times the cube root of 2 times 4 squared. Well, 4 squared is 16, and that times 2 is 32, and then minus 5 times -1 squared. -1 squared is just 1, so that's just minus 5 times 1, so just minus 5. And that goes to -2 is still on top. 4 minus 8 is -4, and then plus 1 is -3. So -2 over -3, that's to the 4th power. And then times the cube root of 32 minus 5, that's 27. So that goes to, let's move it over here. So this is -2 divided by -3. You can cancel out the negatives, turn that into plus over plus, and then 2 to the 4th is that's 2 times 2 times 2 times 2, so that's 4 times 4, which is 16. And then divided by 3 to the 4th is, well, that's 3 times 3 is 9, then times 3 times 3 is 9 times 9, so over 81. And then times the cube root of 27, cube root of 27 is just 3. So we can cancel this out, the 3, divide that by 3, that's 27. So our answer then is just 16 over 27. And that is the value of our original limit here. So the general takeaway from all these problems is that if you've got a limit of a very complicated expression, all you have to do is work your way inside of the expression. Start moving the limit inside of all these operations that are going on using your limit rules. And eventually you'll reach a point where you have limits of individual terms that you can actually compute. And then the problem will just reduce to having numbers instead of limits, and then you can just compute that.